Okay, this one means this one. I take the derivative of this quantity by the coordinate. And then there is no coordinate dependence here. Therefore, this is 0. Okay. If P1 derivative is 0, what is this? Okay, now this line. If this is 0, then what is the answer? If time derivative of the momentum is 0, then what is the time dependence of the momentum? I mean, correct. There is no change in time. Okay? No change in time. This is called invariant of motion. I told you, you see, the very fundamental quantity, invariant of motion. Now, therefore, and look, this does not change in time. Therefore, if I combine this with this one, what is this? Next one. This is integration. You see, you integrate 0 in time, becomes constant. Now, this is a constant. Now, isn't it? This is, we already proved it. This is constant, invariant of motion. Now you take the integrate in time of this differential equation. Now what is this? What is this? You can. Write the solution. Please write the solution. Time. Function of. What is this? Write the answer. Close. Plus what? No, it's all right. Plus some constant.
Yeah.
So that is answer. But that is but when you take t equals 0, this goes to 0. Okay? Therefore, C should be this one. Okay? So this is answer. So you are right. Almost. You forget this one. Okay, good. Look, in America, I give you one nice sign. Not this. Good. Okay, so this means, therefore, look, you know that free motion is velocity never change. Then the coordinate is, this is velocity. So velocity multiplied t is really the motion. Therefore, indeed, the Hamilton equation of motion is quite consistent of your knowledge. Actually, you can go much complicated program here. But then, I already told you very important things. If you know the invariant of motion, you can find a solution. So this is the reason invariant of motion is very important. Whenever you find the invariant of motion, using this knowledge, actually you can solve Hamilton equation of motion. So you can find the solution. Now, in general, free motion is a very simple example. Usually there is a potential. Equation of motion is more complicated. But now I go to the next line. No matter how complicated the motion system is, let's consider very, very complicated system. But by chance, our Hamiltonian is only depend on the momentum and no coordinate. Suppose that is the case. Let's think about Hamilton equation of motion. First line, okay, I will write a set of P, okay? So that I just abbreviate this one, divided by Pi. That is the first line. And now, I is arbitrary. So I will ask, say, then U. What is this? 0. So this is 0. Therefore, PIT is constant. Isn't it? Therefore, in this Hamiltonian system, every momentum is an invariant of motion. So now you found how many invariant of motion exist? 3n. 3n invariant of motion exist. Even that there is not p squared over 2n, it's more complicated function, but still this is invariant of motion. So now you substitute this solution in here. So this is a constant. Therefore, this is constant, isn't it? No time dependence. Therefore, you can now integrate so this is a solution. And you get every coordinate. This means that suppose you have a Hamiltonian, and by some reason, by accidentally or some reason, you could, there is no such coordinate dependence. Then you found 3n invariant of motion, and you can integrate it, and you can get a solution. Okay.